I fell down a rabbit hole, and it took 5 years for me to climb out. Join me on this wild journey of discovery, one that completely changed how I see our solar system. It all began with the heartbeat that shouldn't exist in a tiny world near the edge of our solar system. Meet Pluto, the little planet that should be dead, but is not. When I saw the first transmitted images of Pluto back in 2015, I couldn't help but ask the question that still haunts me. What is the heat source driving Pluto's ongoing geological activity? Everyone knows what our moon looks like, a barren, gray, cratered ball floating in the night sky. Our moon has been cold, dead, and silent for billions of years. No volcanoes, no winds, no atmosphere, no real geology. And that's exactly what most scientists expected from Pluto. A tiny, frozen, dead world, no internal heat, no air to stir things up, just an ancient ice ball covered in craters. Then, the New Horizons probe flew past in 2015 and everything changed. Our moon is dead because it ran out of internal fuel billions of years ago. And this is precisely what we expected from Pluto. In fact, most scientists assume Pluto, being so much smaller and so much further away, would be even deader. But New Horizons showed us mountains, glaciers, fog, evidence of wind, snow, a frozen lake, and possible cryovolcanoes. On Earth, we think of water as something that flows, and rock as something that stays put. But on Pluto, that relationship is different. Because it is so cold, water ice acts as the bedrock. It's as hard as granite, forming the jagged 20,000-foot peaks of Tenzing Montes. Meanwhile, Pluto's glacial material, the stuff that actually flows and carves the landscape, isn't water. It's nitrogen, the same gas we breathe on Earth, frozen into a plastic solid, acting exactly like the glaciers we see in the Alps. On this frozen world, the weather is driven by sublimation, nitrogen ice vanishing straight to vapor like dry ice, never melting, creating a landscape that is constantly being reshaped by its own atmosphere. The surface isn't merely not dead. It screams of an active engine beneath the frost. But Pluto is too small and cold for ancient radioactive decay to still power it. So what keeps it alive? That's the mystery and our adventure. Everyone knows how the moon pulls on the oceans, creating high and low tides. The moon also slightly deforms the Earth itself, tiny bulges rising and falling by centimeters. But those bulges don't just move rock, they heat it. Every flex, every squeeze converts gravitational motion into thermal energy through internal friction. To feel this yourself, bend a paperclip back and forth. The hinge gets hot. That is flex energy. Now, imagine that same tidal flex push and pull, but cranked up to extreme levels. Jupiter is over 300 times more massive than the Earth, and its 4 biggest moons, Io, Europa, Ganymede, and Callisto, feel that gravity intensely. The moons get stretched and squeezed as they orbit. Just like Earth's oceans respond to our moon, but the effect is far stronger because Jupiter is so big and the moons are relatively close. Here's where it gets fascinating. These 4 moons of Jupiter started with roughly the same mix of rock and ice billions of years ago. But Jupiter's tidal flexing turned them into completely different worlds depending on how close they are to the giant planet. Io orbits closest, stretched by Jupiter's gravity like dough, in a relentless tidal rhythm. This flexing generates colossal friction, melting rock and fueling hundreds of active volcanoes. The surface is a hellscape of lava and sulfur plumes, Light gases boiled away long ago, leaving only bare rock. Tidal heating makes it the most volcanically active body in the entire solar system. Europa orbits one step further out, flexing less violently than Io, but enough to thaw ice from within. This sustains a global ocean beneath a shell cracked by tidal stress. Ganymede, still farther out, flexes gently. Buried oceans persist between ice and rock layers, but the crust remains ancient and largely intact. Heat lingers, but quietly. Callisto, most distant, stretches too faintly to thaw. Rock remains locked in primordial ice, frozen, static, and geologically dead. Jupiter's gravity is a single engine driving a spectrum of worlds. The closer the orbit, the harder the kneading, the hotter the interior, and the more volatiles boil away, leaving rock bare and restless. Step outward, and the flexing cools, preserving ices, quieting geology, until distance renders the engine silent. Same ingredients, only the thermostat changes. Could this same tidal energy seen at these 4 moons explain Pluto's heat source? Scientists have concluded no. Here's the puzzle. Pluto and Charon orbit in a tight, perfect circle. No ellipse, no variation. They're mutually locked, each staring at the other's same face forever. In this state, tidal flexing flatlines. No changing distance means no stretching. No misalignment means no friction. The kneading stops completely. That's exactly why scientists ruled it out. Circular orbits should mean zero heat. So if not tidal flexing, what powers Pluto? Mainstream science falls back on 2 sources. A giant impact billions of years ago, forming Charon and blasting out the basin we call Sputnik Planitia, and radioactive decay in Pluto's rocky core, a slow heat trickle fading over billions of years. Both are needed to maintain what the science models require, a hidden subsurface ocean beneath the ice. Their concept is that liquid water, buried deep, provides the mass and mobility to explain the active terrain we see. But both raise immediate problems. Take the impact theory. If Sputnik Planitia is an ancient crater, where are the scars? No high crater walls, no blanket of ejected debris. Other giant basins across the solar system wear these badges. Sputnik Planitia looks more like a smooth, filled-in depression, flowing with ice like a volcanic caldera, not blasted by a collision. No impact crater stays active for billions of years. An impact is a violent moment. Rock slams in, blasts a hole, throws debris, builds rim walls. But once the dust settles, the basin cools. It becomes a quiet scar, not a living feature that keeps flowing or erupting. Look anywhere in the solar system. 0 craters remain geologically active billions of years after the crash. Ancient impact scars, like Mars's Hellas Basin, are filled with sediment and wind deposits, not sustained internal activity. Now compare Sputnik Planitia. No widespread ejecta blanket, no secondary impact chains, no high crater walls. Just a broad, subtle ridge surrounding a smooth, nitrogen ice interior with active convection and young terrain. If this were a typical impact scar, it should be quiet and degraded. Instead, Pluto's heart looks freshly renewed, with flowing ices and wind-carved ripples. Something keeps it alive long after any impact would have gone cold. The radioactive heat concept is just as weak as the impact theory. Pluto is small, 2/3 the moon's diameter, so it loses heat fast. Radioactive decay produces only a weak, fading trickle, not enough to sustain convection, nor to keep a subsurface ocean liquid for billions of years. Pluto should be geologically dead, like our moon, not churning with fresh ice flows. But Pluto didn't freeze. If Pluto should be frozen, we need to find a world that actually is. Meet Varuna, a smaller Kuiper Belt object, same neighborhood, same age. But Varuna is Pluto's opposite. Dark, reddish, cratered, geologically dead. While Pluto reflects sunlight like fresh snow, Varuna absorbs it like dirty asphalt. Exactly the soot-covered ice ball you'd expect from Pluto. The difference? Resonance. Varuna circles Neptune at roughly the same distance, same inclined plane, close enough to feel the gravity, but without that resonant rhythmic pulse, its orbit stays circular. No periodic squeeze, no heat. The interior stays primordial. Tidal flex energy flatlines. Pluto, by contrast, caught a 3-2 resonance, 2 orbits for every 3 of Neptune's. This isn't passive. It's the same periodic gravitational squeeze we saw with Jupiter needing its moons, only slower. Every time Neptune catches up in that rhythm, gravity needs Pluto's interior, maintaining that high rock-to-ice ratio and preventing the deep freeze that killed Varuna's geology. Same dough, different kneading. One died, one didn't. Pluto's resonance with Neptune prevents the deep freeze. It doesn't carve fresh mountains or push nitrogen across the surface. For that, you need friction, an event violent enough to crack the shell and soften the ice, creating the weak points that later cycles could grind. The evidence for that mechanism is found in a moon called Triton that orbits Neptune today. Triton is Pluto's twin, same size, same density, same surface ices. Both worlds are geologically active, alive, despite being too small and too old to still be hot. Every moon born in place inherits its planet's spin, prograde, equatorial, orderly. It's the signature of local birth. But Triton orbits Neptune backward, the wrong way, tilted 23 degrees off the solar plane. It didn't form there, it was captured. Clean captures require chaos, a 3-body tug-of-war where something gets flung outward so something else can be pulled in. Now look at Charon, Pluto's binary companion. Oddly, Triton matches Pluto perfectly. Same material, same formation time, same initial neighborhood. But Charon, by contrast, matches Uranus's moons, Ariel and Umbriel. Same size range, same water ice and ammonia makeup, same gray baked surface. Charon is gray because it baked somewhere warmer, closer to the sun for millions of years before migrating outward. Pluto is red because at this distance, the extreme cold preserves fresh methane frost. Charon's red chemistry burned off before it arrived. The mismatch is obvious. The original binary, billions of years ago, wasn't Pluto-Charon, it was Pluto-Triton, twins born together in the Kuiper Belt. Then came the migration chaos. As the Pluto-Triton binary skimmed Neptune's gravity, they intersected with Charon, also scattering outward from the Uranus zone. For a brief period, 4 bodies engaged: Neptune, Triton, Pluto, and the interloper, Charon. The instability stripped Triton away to become Neptune's captured moon, accounting for its backward orbit today, while Charon lost enough velocity to fall into orbit around Pluto. The new Pluto-Charon pair rebounded into the outer Kuiper Belt. That exchange happened hundreds of millions of years ago. It established the binary and drove ammonia-rich material up from below, right where tidal bulge forces concentrated, seeding the weakness that would become Sputnik Planitia. Charon sits antipodal to Sputnik Planitia, directly across Pluto's globe, like how Earth's antipode to North America is the Indian Ocean. During the ancient chaos, tidal forces emplaced ammonia hydrates at that point, not soft spots, shear zones. permanent weak points with pronounced cleavage planes where the ice can slide under stress rather than fracture. New Horizons later detected that ammonia at Virgil Fosse, fractures scarring the terrain near the antipode, confirming it sits exposed at the surface exactly where the shear zones should be. The primordial heat faded long ago. That violence has settled into a locked dance. The capture event isn't what's grinding Pluto today. What matters is where that violence left him. That near-surface weakening is the key. It lets Charon's tidal bulge torque focus friction right at the seam. Two ice sheets rubbing together, creating localized heat and pressure that collapses into a caldera-like depression. Exactly what we see in Sputnik. While the orbit stays circular, the axis does not. Three rhythms now work that scar. First, the axial wobble. On Earth, a 2.5-degree wobble drives ice ages. Pluto's axial tilt swings 23 degrees, not a mere 2.5. These violent oscillations blast one pole, then the other with the sun's heat, sublimating nitrogen and driving the seasonal migration of entire landscapes, hundreds of meters of ice relocating with the sunlight. Second, Neptune's 3-2 resonance delivers the steady gravitational pulse that prevents deep freeze, keeping the interior mobile enough to respond when squeezed. Third, the torque itself. While solar heat moves nitrogen across the globe, Charon's pull grinds those ammonia-rich sheets at the antipode. The friction generates its own heat, mechanical, not solar, concentrated at the weak seam, powering convection, the circular churning of nitrogen ice that creates the polygonal cells we see in Sputnik. Sunlight drives the weather, friction drives the geology. Two engines, one breathing world. You can see the exhaust. In 2017, studying New Horizons photos, I spotted the first fingerprint. Sastrugi, sharp wind-sculpted ridges of hard snow, identical to those in Antarctica. 6 months later, a science paper confirmed what I'd suspected. Methane ice dunes sculpted by wind, distinguishing them from the sublimation pits others had proposed. For wind to carve ice at minus 380 degrees, you need an atmosphere dense enough to sustain wind. That requires heat. Heat that's migrating nitrogen from pole to pole. Heat that's grinding at the antipode, keeping the engine running long after any ancient battery should have died. All of it concentrates at the antipode, directly opposite Charon, exactly where the ancient capture left the shell mechanically weak, exactly where the binary's axial wobble flexes the ice. The violence didn't end when the orbit settled. It simply found a new rhythm, grinding away at the scar, keeping Pluto alive. Mainstream models try to explain Pluto's heartbeat with a chain of dominoes 4 billion years tall. They don't describe a functional engine, but a house of cards, a forced impact that demands an ocean, that demands a planetary roll, that ends in a lucky alignment. To see why these patches of their model keeps coming, you have to understand the consistency trap. It began when Bill McKinnon established the giant impact as the only explanation for the Pluto-Charon binary. Once that became gospel, every piece of data had to squeeze through that keyhole, no matter how many miracles it required. First came the lava lamp patch. In 2005, Robin Canop's model had to treat Pluto and Charon like weightless fluids, two blobs in a lava lamp, to make the impact math work. Real rock has strength, real ice resists. But if she included that physics, the impact wouldn't have made the Pluto we see. So the model simply ignored it. Then came the Mascon patch. When New Horizons found Sputnik Planitia sitting exactly opposite Charon, the theory demanded a mass concentration, a super heavy spot that would tip the planet over in a process called true polar wonder. But Sputnik is a hole, 2 miles deep. To make a hole heavy, they invented an ocean bulging up from below. The catch? Recent gravity models show Sputnik isn't a positive anomaly at all. It's negative, a mass deficit. The thick ice shell hides empty space, not liquid water pushing up from below. To keep the true polar wonder theory alive, the models now require the ocean formed in the past, then refroze, adding yet another patch. Then, the crater counting model hits a wall. Kelsey Singer's analysis revealed a striking deficit. Pluto's surface shows almost no small craters. The interpretation? The Kuiper Belt must be mysteriously empty of small rocks. But that logic ignores the weather. The same sublimation cycles and wind I spotted carving sastrugi in 2017. The model reads an empty sky to prove an ancient surface, while the ground beneath is actively erasing craters as fast as they form. The crater counters themselves admit uncertainties in excess of 2 billion years and call Pluto's ages fraught with uncertainty. And yet they claim it as proof the impact happened over 4 billion years ago. The final patch came in 2025. Aideen Denton realized the lava lamp and Mascon didn't fit the physics, so she tore them down and introduced the 3-hour kiss and capture miracle. For her model to work, Pluto had to be spinning once every 3 hours. We observe it spinning once every 153 hours. That's a 5,000% error. Like explaining your car's current speed by claiming it once traveled at Mach 5. The dial wasn't turned to match reality, it was turned until the impact finally worked. If the 3-hour spin sounds impossible, that's because we can see what it actually looks like. Meet Haumea. Same neighborhood, same ice rock mix, spins every 3.9 hours, almost exactly the speed Denton needs for Pluto. And look at it. Not a sphere, a stretched football. Centrifugal force is literally pulling it apart at the seams. Pluto spins every 153 hours and is nearly a perfect sphere, not a football, no centrifugal stretch. Haumea spins fast enough to distort, Pluto spins slow enough to stay round. If Pluto ever hit 3 hours, it would look like Haumea. It doesn't. But there's another fingerprint Haumea carries that Pluto lacks: a family. When that spin-up happened, it sprayed debris across the solar system. Chunks of ice we can still track today. Pluto has no family, no debris field, no fingerprints of a massive spin-up event at all. The 3-hour spin is a phantom, a dial cranked to save a broken equation. We don't need a miracle to explain the heat. We need the engine that's running right now. Step back and you see the architecture. A rare impact without ejecta, a radioactive core in a tiny world sustaining a long-lived ocean, a perfectly timed reorientation of the planet, a gravity anomaly that switches from positive to negative yet still aligns, by sheer luck, exactly opposite Charon. Each step depends on the previous one standing perfectly still for billions of years. Those aren't vanishing odds, they're zero. This isn't deduction, it's desperation. It's confirmation bias, holding up a house of cards. We went to Pluto expecting a fossil. Instead, we found a planet with a heartbeat. If Pluto is heated by tidal flex, not by billion-year-old accidents, then it's not a lucky exception. It follows the same rules as Io, Europa, and Triton. The little planet at the edge of the solar system is alive, and it's telling us to look again. Thanks for making it this far. If this reframed how you see the edge of our solar system, hit like and subscribe. It tells the algorithm this story deserves shelf space next to the mainstream narratives and helps other curious minds find their way here.